Good afternoon all. So today I, Dr. Vinkel Aror, Assistant Professor in Department of Food Engineering at Nifton, Kundli, will be discussing about the aspect of Internet of Things in cold chain logistics. I think today when the things have exceeded the number of people, the things starts communicating, taking decisions, and then they are applied in each and every aspect of the life. So now let us see how the things do affect the cold chain. Today we will be discussing about the Internet of Things. Basically it is the network of physical objects or the things that are embedded with the sensors which are taking the input signals, a processing software, and then the other technologies for the purpose of connecting, exchanging, storing data and data with other devices and systems over the internet. So by means of a low computing, the cloud, the big data, analytics and mobile technologies, physical things can share, collect data with the minimum human intervention. So I think this is an important aspect where the things, they communicate, take decision, collect data, and then they provide a decision. What about IoT in cold chain? Now basically this Internet of Things is normally used in cold chain for data monitoring, real-time data access, for generating automated reports of the data, shipment tracking, reduced operational cost, reduction in spoilage of goods, minimizing risk and error. Now let us discuss the first aspect of the IoT, that is the temperature monitoring. Normally the manual temperature monitoring is very time consuming process which requires a constant manpower which will be taking the manual reading, and then for entering the data into the system, again this is a very time extensive and cost extensive process. So IoT will help to provide a continuous temperature monitoring throughout the cold chain. During transportation, the sensors can be used to monitor temperature within the vehicle, temperature of the product, also gathering and sharing the data in the real time. Now here this is the important aspect with regards to the monitoring, where the real-time monitoring is required for some of the perishable commodities like ice creams, meat and other perishable products. Now here for monitoring temperature, there are two important components: what category and what type of data we want to monitor. First category is the sensors, which will be the recording. Second is the data loggers. So data loggers basically are used to generate the data continuously over a period of time and then generate reports. Now let us first talk of the temperature sensors. Provides the temperature measurement in readable form through an electrical signal. So it increase in voltage of the die, the temperature will also increase. So this is the basic concept about the temperature sensor. Now if you talk of the classes, there are two broad categories. One is the contact temperature sensors and then the non-contact or contactless temperature sensors. Now here you have a temperature which is RTD, which is measuring the degree of hotness and coldness in any object by direct contact. Direct contact means that this particular sensor requires a contact with the product or the space where the temperature has to be recorded. Second category is the contactless or non-contact type temperature sensors. So here this measure the degree of hotness or coldness from the radiation that is emitted by the heat source. So every body is emitting a radiation. So these radiations, they are detected and then through a thermopile they are converted into heat, and this heat energy is basically converted into an electrical signal to monitor temperature. So here in Corona, this particular infrared temperature sensor, basically a non-contact type sensor, was used for measuring the temperature. Then let us discuss the other type, what is the basic principle in the RTT type or the resistance temperature detector. So here basically you have a ceramic bobbin or a thin film RTD element on which a wire. This wire can be made up of different materials, and depending upon the resistance, the temperature will be determined. So this is the particular ceramic bobbin, and on which this is the costliest type of the RTD thermometer, where the platinum wire is used to determine the temperature. Now this works on a principle of resistance of the RTD with the temperature. As the temperature increases, material resistance also increases. So this is the basic principle behind this RTD sensor. So this is made up of nickel, platinum and copper. The most accurate one and costliest one are the platinum. So these sensors are used where there is a possibility of having a direct contact with the product. Next concept is the thermocouple. Now here we are using two dissimilar metals. So these are made up of two wires. They are dissimilar wires. They are connected at 2 points, and one junction is placed in the area where the space or region is hot, and other is placed at the colder region. So because of this, the electrical signal is generated, and from that electrical signal is converted into the temperature. So basically we are using metal which include copper or tungsten. This is a type T thermocouple. Then iron and tungsten, basically this is a type J. Chromal and aluminum, this is type K. So these are the different thermocouples which we are using inside the thermocouples. So basically the voltage between the two wires reflect the change in temperature. So here different types of thermocouples, they are available in the market for measuring the temperature. You can have the temperature of as low as minus 200 degrees Celsius, and you can have as high as 1750 degrees Celsius, and they are very low cost, means you can install these sensors at a very low cost. At the same time you can have a multi-channel displays. It means a different, for example, in temperature mapping in a cold room you require, let us say, 20 thermocouples. So you can have a multi-channel temperature display unit where you can see the temperature at each location, and then you categorize as hot or cold spots. Next category is the negative temperature coefficient, which is called as basically thermistor. So they are very precise, very predictable. Large changes in the alteration of different temperature can be determined very easily. Now it means that the reflection of the temperature occurs very rapidly and accurately. At low temperature it provides huge resistance, and as the temperature rises the resistance drops very quickly. So basically this is a schematic of this thermistor, wherein you have a sintered electrode, and then this is the thermistor crystal, and then you have a doughnut wire. This wire basically is made up of nickel iron ore, and then encased in oxygen free conductivity copper shell. So basically if you see, this is the actual picture of the NTC thermistor, and here basically this is the resistance and this is the temperature range for microamperage. So here if you see 5 kilo ohm, you can have the temperature from minus 55 to minus 2, and if you are using a 100 microampere range you can measure the temperature of minus 22 plus 33, and likewise for 10 kilo ohm you will be having minus 45 to plus 13 and minus 8 to plus 50 for 100 microampere. So basically this is the range of temperature depending upon the resistance for a given temperature of 25 degrees. Then there is a thermometer which is mercury filled or glass filled. Basically mercury is now no longer used. We are using the ethanol, where the expansion takes place once the temperature rises, and this lies in a capillary tube which is calibrated in terms of the temperature. Nowadays for low cost and safety, ethanol is widely recommended. The category of infrared thermometers, basically they are using, let us say this is the object whose temperature is to be measured. So they are emitting the infrared rays. These infrared rays, through a lens, they are focused on a thermopile. So this thermopile, they absorb the infrared radiation and convert this into heat. This heat input is converted into an electrical signal through a PCB controller, and then it is generated as an output signal. So this infrared processes utilize electrical signal to determine the body temperature. So this temperature range can be as low as minus 50 degrees Celsius to up as high as plus 2200 degrees Celsius. This the distance from the object also affects the accuracy of such kind of thermometers. Nowadays, low cost solutions are also available in the market for measurement of the temperature. Basically, these are the semiconductor based sensors. They work on the dual integrated circuits. They consist of two diodes which are very similar with voltage and temperature, voltage and current characteristics at the temperature sensitivity. They are very slow response. This is the one issue which makes it least suitable for the industrial applications. So wherein the response time is from 5 to 6 seconds and across a temperature range of -70 to 150. However, for prototyping and at low cost solutions with Arduino, such kind of semiconductor based sensors are also used. Temperature data loggers. Now here the important requirement of a cold chain industry is to monitor the temperature over a wide range of period and then to have the entries to ensure that the quality of the product is retained. Now here let us say this is a Bluetooth transmitted data logger which is placed inside the vehicle, which is a delivery vehicle. Now upon the arrival of the product, it will be connected with the smartphone on the tablet, and then this data will be stored within the cloud and which can be viewed at any time. So here this particular temperature data logger will maintain the record, at the same time record the temperature at a given time duration so as to ensure that the product is safe for consumption. Nowadays real-time temperature monitoring is also one important aspect. Now you can have a 24/7 by 365. It means you can measure the temperature 24 hours, 7 days and up to 365 days a year. When within IoT sensors, the temperature of the shipment is monitored, logged automatically, and then the reports are generated. Those temperature reading can be viewed in real time or on any internet connected device from anywhere around the world. So you can find out the product which has been imported, at what temperature it was maintained, which temperature it is stored, and from there you can ensure the quality and the safety of it. No longer the concept of driver with a pencil for monitoring the temperature. So this is the old concept which was there in the cold chain. Another important aspect of data logger, they are very handy also. Such kind of single-use PDF temperature data logger is available in the market. You can record from the period of up to 30 to 180 days. You can have around 16,000 record points, means 16,000 reading you can store. It is very easy to connect via USB. No software is required, no cable is required, and then it will automatically generate the report. Some PDF temperature data loggers are also having LCD screen with power indicators, and overall this temperature increase can also be detected via alarm indicator. Multi-use temperature and humidity data loggers. Now here the humidity is one of the important aspect of the storage. There are data loggers which monitors both temperature as well as humidity of the space. For example, this is the temperature and humidity data logger which can store up to 32,000 data points. Then they can be either wired or they can be wireless. So temperature and humidity measurements, this is via external sensor. Nowadays the probes can be placed at a point where you want to monitor temperature and humidity, and then through wireless contact the data can be transferred to the smartphone. So this has the provision of automatic calculating the dew point and wet bulb temperature. Then there is a modular truck temperature data logger. Now because the trucks, they are transporting the material in the cold chain, so the higher number of data points are required. So this has the capability of storing up to 1,50,000 data points and over a temperature of -30 to -75 degrees Celsius. So they have the inbuilt printing facility as well as the USB connectivity, and the accuracy for such kind of modular temperature control data logger is around ±0.1 degrees Celsius. The important aspect of the cold chain is product identification. Now for this you have a technology called as RFID, that is radio frequency identification. So basically this is a concept which has been the center of this entire cold chain. Within few stream this has become the mainstream in the cold chain. There are three important components inside this particular RFID. One is your RFID tag, which you can program depending upon the code or the class. Then there is a RFID reader. Through an antenna, this RFID reader reads the particular tag, and then this transmits the information to the DBMS, that is database management software. Now how this actually works? So this RFID tag is attached to the product, which is to be stored or transported. This particular tag generates a signal. This signal is detected by an antenna. This antenna receives the stored data from the tag, and it can transmit the data to a reader. Now this RFID reader, it basically is connected to the antenna wirelessly, and then it receives the data from the RFID tag. So this data is transferred to the computer, and from where you can evaluate, and then you can make decision depending upon your requirement or the temperature limits. Now there is a electronic product code tags. These are basically the special kind of tags which follows the EPC standard, that is electronic product code standards. So this was developed by MIT Auto ID Center, and then now it is managed globally by EPC Global, a trade organization. So there are different RFIDs which are available, but the class is very important. For example, class 0. So these are basically called as the passive tags. These are the category of read-only tag, means they are only programmed by the manufacturers. Class 1, these are write ones, read many. Again, this is a category of passive tag. Normally it is having a provision of programming by a consumer, which cannot be reprogrammed. Now the most versatile and the adaptive tags which are available, they are reprogrammable ones. So basically class 2, that is rewritable passive tag. Class 3, which is semi-passive tags. Then active tags, and last is the readers. So all these are the category of reprogrammable tags. So now let us see the RFID standard operating frequencies. Now basically if you have the RFID, what is the operating or the reading range? For example, if you have the frequency of 125 to 134 kilohertz, the reading range will be up to 10 cm. The cost would be very low, and the coupling would be magnetic, and then it will be covered under the standard ISO 11784/85 and ISO 14223. Basically these are very low cost or low frequency tags which are used for animal tagging access, ticketing, smart cards. Then the second category is high frequency. High frequency means 13.56 megahertz. So basically you have the 1 meter range, cost is also low, coupling is magnetic, and the data transfer rate is also higher than as compared to low frequency, covered under D standard, normally used for supply chain, small item management, transportation, anti-theft and library. Important range is ultra high frequency. So basically you have the range from 0 to 10 meters, cost is medium, and here you have the coupling under electromagnetic, covered under the standard ISO 18000 part 6. This is dedicatedly used for security access, supply chain, transportation, vehicle ID, large item managements. Then you have the microwave, that is 2.45 to 5.8 gigahertz. Reading range is 1 meter, cost is very high, and then covered under ISO 18000 subcategory 4. And then you have the security access, vehicle ID, supply chain, inventory management. So this is basically the overall aspect of the low, high and ultra high frequency of the RFID tags. Now how this RFID identifies the specific product. So RFID contains ROM, that is read only memory, which stores the data to identify the object. So RFID tags can save up to 1 KB of data. It means as per EPC Global have developed the standard identification code of 96 bits. Means 8 bit will be for header, 28 bits will be used for manufacturer code, 24 bits will be used to product type code, and 36 bits will be used for unique product ID code. So for ease of human interaction, these bits of the codes are converted into hex or ASIC base. So this is bits converted into hex into ASCII. Now how this is being done? So bits are information units transmitted between RFID tag and the reader. So codes coded using zeros and 1 in a string of 4, this is called as the binary coding. So for example, here if you see, this is the binary code, and here in RFID you can have the memory of around 96 bits. So this is the combination of 96 zeros and 1 which are back scattered in the RFID reader. So this is the binary code. Now here what conversion has been done? So the first step is understanding the bits and then converting into hexadecimal. Now what happens in hexadecimal? So you have around 16 type of characters, okay, that is from letter A to F and number from 0 to 9. So each 4 bit is converted into one hex character. For example, here these 4 binary numbers, they are converted into one hex character, means for 4 bit. So in 96 memory bank can store around 24 hex character. So if this is the binary code for the RFID, it will be converted into hex code, and this is the hex code for this entire product. Now to further shorten this, American Standard Code for Information Exchange, that is ASCII, basically uses 128. Now here each character will represent 2 strings of 4 bit. Now here it will further shorten down the code. For example, here this, if you see the first 4 bits of a string, so 2 strings they make a 1 character of ASCII, and then this particular entire binary code will be converted into ASCII code as OBU3, this with inverted commas, 3H 5B star 5 and inverted comma close. So this will be the code available for the ASCII. So this will be graphically represented in the DBMS. Now here what is the basic difference between RFID tags and barcodes? Now RFID tags, they identify the object without a direct line or sight, means there will be no direct contact, but this requires, barcode requires direct line or the sight for the scanning. The scan items inch or feet away, but this requires a very close proximity for the barcode to be scanned. This you can use for real-time update. This is only real-time, cannot be changed. RFID requires power source, but here barcodes, they do not require any power source. They are just printed and readable for the scanning. Read time is less than 100 milliseconds. So read time is more than or equal to half a second. So basically, if you see the the scanning time, it is very fast as compared to barcode. Contains different sensors, antenna, and covered with the plastic layer. So printed on the outside surface of the package and easy to get wear. Now next important aspect of the logistic is your global positioning system, that is the GPS. Means the from storage it has to be dispatched, and then for monitoring the temperature and humidity, a global positioning system is important aspect of the cold chain logistic. Now here if you see, the product is traveling from the processing facility to the retail outlets, and from retail outlet to the consumer till it is consumed. So here The monitoring of the temperature and humidity across the profile is very important, and this requires a real-time tracking. So what you can do, tracking current location of the shipment, you can use GPS. It provides the real-time information. Then compared to RFID, it transfers information at different intervals using RFID, which are placed at the different locations. Combining these devices with temperature and humidity, it can track different parameters with real-time location. Now here, what is the concept? Here we are using GPRS or GSM module. So this is the cargo in where you have the RFID tags. Then you have a GSM module wherein this generates a signal, and then this will be continuously tracked through a GPS satellite. From here, this GPRS module will be connected to the cell or the tower, and this tower will be ensuring that this data is transferred to the internet. Once the data is stored, it will be taken by the central server and then to the workstation. Now here, if you see, this GPS will be installed in the vehicle, and then this will be continuously monitoring the temperature and humidity of the. So that's why it is called as the real-time tracking. Then the important aspect of IoT is artificial intelligence. Now, what are the various aspects of artificial intelligence? That is covering AI, it is cybernetics, it is problem solving, it is deep learning, it is machine learning, it is robotics, it is decision making or the predictive modeling through neural networks. So this is the most demanding technology of the 21st century, and then it seeks the information and analyze the data to recognize the business patterns. So it has basically changed the way the packages move around the world, from predictive to forecasting to autonomous vehicle to AGVs. This is one thing the AI has given to the cold chain sector. Now, AI in logistic transportation. So unhindered workflow of the cargo, ease of shipment management and optimization. These freight managers get huge amount of data, that is in terms of fuel, price, resourcing, shipment, location, temperature, etc. If it is not collected, processed quickly, the data will pile up and this will be very unproductive. So basically, statistical techniques are used to analyze the big data and determine the historical pattern of demand and supply, and by using the predictive analysis techniques. Now, AI in forecasting and inventory management. So the demands are driving the market. So future forecasting will be very helpful in capacity building, in planning, in human resource management, in R&D, inventory control, etc. So with AI, you can easily predict the demand. You can find out what is the product life cycle, what is the growth of the market, when the new product is to be launched. So with this, you can have a better planning, ensures minimal inventory cost, and at the same time constant availability as per the consumer need. Now Google has put AI in charge of the data centers for the cooling system. Now here, the cooling systems, they are controlled by the IoT sensors, which are fed up with deep neural networks, which will predict how different choices will affect the future consumptions. By using the machine learning AI, Google has been able to use the data centers more efficiently. At the same time, they have reduced the energy expend by 40% in this cooling. AI in robotics and automation. So the next level thing in the warehouse management or in the cold chain logistic part is the robotics and automation. So specific order of packaging, package selection, picking, handling requires the highest number of workers. So this is the most labor extensive part of the cold chain. Now AI will automatically identify every product because of the code, data, location, FIFO information, that is first in first out information. Then AI integrated with robotics, identifying the movements of the product in the large cold store, warehouse, distributor centers. They can identify the product in less than 0.2 seconds and move to the desired location. So these are the inventory controls, warehouse management robots, AGVs, which are nowadays available, and they will be sorting, grading the food products depending upon the shape, color, and then the storage information. Now the AI and robotics, they are changing the concept of automation and robotics in the industry, and now this video will help us see and predict the future. Let us see the future. Future is virtual reality, augmented reality, and mixed reality, where we can see, we can simulate the things, we can understand the things, and then we can augment the reality. Let us see the future. Future is virtual reality, augmented reality, and mixed reality, where we can see, we can simulate the things, we can understand the things, and then we can augment the reality.
In NVIDIA AI and simulation solutions are delivering better than ever efficiency and intelligence to the supply chain, ensuring retailers never miss a beat in meeting customers' expectations. From the moment a vehicle first approaches a distribution center, AI streamlines the receival process. With computer vision, retailers have the ability to detect and identify arriving vehicles and count the boxes as they're unloaded, reading their labels for quick identification. AI has already made sure that these products are the ones in demand. With AI, forecasting is smarter and more accurate, giving retailers insight into what their customers want and when. As boxes move down the conveyor, intelligent automation monitors their progress. AI can adjust the conveyor speed, speeding up or slowing down to maximize employee productivity and safety. Congestion is avoided as computer vision applications identify when packages are tilted or sitting too close together. By automatically adjusting the conveyor speed, AI eliminates downtime, which can cost retailers $3,000 to $5,000 per minute. The same intelligent automation boosts quality control, identifying damaged boxes to ensure they never make it into a disappointed customer's hands. And that's just the beginning of the optimizations that AI can bring to the supply chain. NVIDIA Omniverse makes it possible to simulate distribution center design, improving workflows and throughput with photorealistic, physically accurate virtual environments. Retailers can develop, test, and manage AI-powered distribution centers in a digital world, and then bring those optimizations into the real world. Global teams are using Omniverse to design factories and distribution centers in real time. Digital human simulations test new workflows for employee ergonomics and productivity, and robots are trained and operated with the NVIDIA Isaac robotics platform, creating the most efficient layout. These AI applications are deployed efficiently and securely at the edge with NVIDIA Fleet Command. In the real world, autonomous mobile robots safely navigate the distribution center floor to sort, store, retrieve, and palletize products. This removes tedious manual labor from employees' shoulders and increases efficiency and throughput. With NVIDIA Reopt, these robots also bring new efficiencies to order picking. Using simulation, they're trained to find the best routes in a virtual warehouse. When those learnings are brought into the real distribution center, orders are picked and prepared for shipment more quickly. Ultimately, AI solutions are the key to creating the distribution center of the future, increasing throughput with computer vision applications, pick-and-place robots, and autonomous vehicles. From initial receival to truck loading and dispatching, AI adds intelligence that streamlines the material handling process. And machine learning recommends ideal routes for deliveries, so once on the road, truck drivers can get orders to customers faster and within shorter time windows. Explore our retail solutions on NVIDIA.com to learn more about how NVIDIA is optimizing every part of the retail supply chain.
So in this module you have seen how the IoT will be controlling the cold chain logistics in the coming future and improve the efficiencies and work dependencies. And now the time has come where the intelligent things need to communicate and then assist the humans in making the decisions. So with this, thank you all.